Hey everyone, I'm Haritha. I work with the TiDB team at Databricks, and I'm here today to talk about why Databricks chose TiDB, and also to talk a little about our experiences with managing like database deployments at scale, specifically TiDB. I think if you're in the data science or machine learning world, you've probably heard of Databricks before. But in case you haven't, Databricks is a front runner in the data and AI space. So we have around like 10,000 plus enterprise customers globally, and you might be familiar with some of our products. So we are basically the inventor of the lakehouse architecture. For example, Delta Lake is a product which sort of fits into that. We have Unity Catalog, which is basically a governance solution for managing like different types of structured and unstructured data sources. We have Spark, which is the compute engine, which is like commonly used for big data analytics workloads. We also have MLflow, which is a platform for basically kind of building machine learning models, running experiments on them, keeping track of them, and that kind of thing. We also have DBRX, which is the LLM model released by Databricks. So this is basically like kind of like an introduction into the kind of features and products which are basically backed by the database infrastructure we are going to talk about. Now, when we talk about databases at Databricks, the first thing to know is what exactly do we power, right? The kind of data we sort of like have covers like customer accounts and all kinds of details like clusters, jobs, models, and stuff. So if you think about it, like let's say you're a data engineer, your team uses Databricks as a platform. You basically go and start your day, maybe pull up a notebook, start doing some writing some code, like running them. Every single interaction of yours is basically going to be backed by the databases we're talking about. So internally at Databricks, if you talk about the scale, one thing to know about Databricks is that we are a regional deployment model. What that means is we are basically we provide customers ways to run their workloads on top of cloud provider compute. So our customers basically use compute from different regions on different cloud providers. So what that means is, if a customer wants to use, in Azure region 1, they want to run their workloads, all of the infrastructure which we power that should also be present in that region for reasons like availability and user experience, latency, cost, and so on. So what that means is we don't have to manage one or two deployments. We end up having like 100 deployments over each region for each cloud provider, and that is something which has been one of the challenges which we face. Now, in addition to that, we also follow the kind of, like in MySQL at least, we followed the single tenant architecture we learned about earlier today. What that means is, let's say a team wants to build a product. What they essentially do is they kind of, bring up their own instance, start building their product on that particular MySQL instance, and it sort of grows naturally from there. So that means for a company of our engineering size and stuff, you end up with hundreds of MySQL instances in each of those regions. So you can understand how that sort of ends up with like a huge number of databases instances in total. And each region also has a few hundred terabytes. So that also kind of adds up overall to like a huge data volume. And we've been around for around 10 years now. And all of this was originally on MySQL. But we have been facing some challenges with MySQL at scale, as you've probably heard like multiple times today. So the challenges are essentially the same. First one is scalability. So back in 2020, our team essentially did an experiment sort of thinking through what will the business actually need from infrastructure 5 years ahead or 10 years ahead. And at that time, they realized that we kind of really need to do something because given how fast the business was growing, we had to do something to make sure that our infrastructure would actually scale with the business. And that was when we started, figuring out like what we need to do. And first, we started with enumerating the challenges which we are basically trying to solve. The first one is, of course, scalability. MySQL has actually worked out pretty well for like small use cases. When you're just starting up with a new product, it's very easy to spin up and sort of like get started. But the challenge comes in when your product has been in production for a few years and you've had a lot of customer adoption and then you start scaling. So that is the point where we found out that critical services often get bottlenecked with MySQL. And in terms of, that's one major thing. And the operational overhead, especially for the kind of deployment we talked about, that is, you need a deployment in every region and every cloud. So that kind of also adds up to the toil. It also means that our infrastructure team has to maintain 3 different types of infrastructure. Like for each cloud, you build every single workflow, and you sort of have to manage that over the years. So this is also something we've been dealing with. Now, when we started, doing this kind of thought experiment back in 2020, we came up with a list of features which Databricks kind of requires from a database. So these are essentially, first thing is high availability and disaster recovery. So one of the main problems we've had with MySQL is, frequent database restarts, which have impact on your services and stuff. We also wanted 0 downtime updates to software and infrastructure. Specifically, you want to be able to, say, do a upgrade of your database, or you want to be able to do some schema migrations on your tables, and you want to do all of that with 0 downtime, which was something we were lacking at that point. And scalability, the ability to sort of horizontally scale with business demands is also a critical thing for us. And because we have a 10-year footprint of MySQL, what is also important for us is to make sure that the solution is MySQL compatible. Doesn't have to be 100%, but we need to be able to sort of migrate it without having to ask 100 teams to rewrite all of their code. And again, deployment is another critical aspect. You're going to basically do it hundreds of times. So you want to make sure that you have a way to manage your deployments with low overhead. And we're also looking for maturity and ecosystem. So we want to make sure that the solution we have has rich tooling, documentation, a community around it, and so on. And the last aspect we're looking for is cost. We want to have minimal cost overhead for our solution. And by cost, there are 2 things. One is the infra cost, which is the cost you just basically pay over the bare metal compute cost, which you'll anyway need. The overhead you sort of pay on top of that. So for example, if you're using cloud managed MySQL, that's probably quite a bit of a premium. And the other type of overhead we're talking about is also operational overhead, which means that how many people do you actually need to kind of manage a deployment of that scale for multiple years, and does it keep growing over time, and those kind of aspects. Now, we explored different options, you might have heard about sharding and other alternatives which were explored, and we eventually landed on TiDB because it kind of checked most of our boxes. So high availability, you might have seen the design today multiple times. You have multiple components, each of which is independently scalable with no single point of failure and automatic redistribution of data during any scaling operation. All of these are good features for us. 0 downtime updates, this has been super critical for us. So in TiDB, we are able to do upgrades without any service interruption, which was not the case earlier. And online DDL has been a game-changing feature for us because schema migrations was a pain point, especially because you have hundreds of teams, each of them trying to do their stuff. So this was also something which has been super helpful for us. We also wanted a horizontally scalable solution, which we have. You are able to easily scale up. And in terms of MySQL compatibility, while it's not 100%, it's pretty close. And we have found that we are sort of able to manage it to some extent. There are 2 kinds of things, feature compatibility, that is, maybe you're using a feature, a DDL statement which works in MySQL but not in TiDB. That is one case. And the other case is also, which is actually more critical. Everything works fine functionally, but you find that the query plan or performance has regressed when you switch to TiDB. These are the 2 kind of cases which we have learned. But we have also found that these are manageable. The migration is smoother than what you expect. And by using a self-managed Kubernetes deployment, we're also able to accomplish a goal of sort of having multi-cloud, multi-region deployments, which are kind of uniform, so it's easy for us to manage compared to our current solution, which is different cloud-managed MySQL. And like I said, we decided that we'll go to TiDB. We started using TiDB and so on. And let's talk about where we are today. So 2021 was when we actually started, experimenting with TiDB, actually using it for our workloads and so on. And our first production deployment was in 2023, like mid-2023. So you might wonder, why did it take that long? So the reason was how we approached our migration. So when we did our migration, we did not pick a small use case and sort of try to onboard that onto TiDB. What we actually did was took the single largest database customer of Databricks, the one with the highest QPS, and we actually tried to migrate that. Now, this has like two reasons, essentially. One is it was a real test of TiDB. You want to make sure that the solution you're going for actually covers your real use case. And there was also another practical reason. So we have this concept of drop-dead dates for our products, which is basically the time at which we believe that at our current scale of how Databricks is growing, when a product will just not be able to scale up on MySQL any further. So the most critical service we had was the one which fell under that category. So we actually tackled the most complex, largest database which we had, and we started with moving that to TiDB. And we were able to do a successful deployment in mid-2023. Since then, our migration pace has sped up significantly. So today, we have deployments in 50+ regions across 2 clouds, like Azure and AWS. And in all of these cases, we are running only the most critical workloads. We are still following our strategy of picking only the largest databases and then moving them to TiDB. And I think as of today, we have around 300+ production clusters, which my team is managing. And it's, of course, growing continuously because we are still in the middle of migrations right now. Now, what we have learned from our experiences with this process is that it's in the beginning, maybe 2-3 years back, when we talk about managing TiDB, we might talk about how to handle a single cluster and stuff. But what we have learned is that over time, we need to stop thinking of individual clusters and think of it as a fleet. And that has been our reasoning towards building our own control plane. So a control plane is essentially an internal kind of software used by the platform team to manage the lifecycle of anything related to TiDB, like clusters, databases, and so on. Now, what we have realized is, of course, we use the TiDB Kubernetes operator to deploy our clusters and so on. But what we have realized is, in general, anything to do with database deployments is not very straightforward, which means that creating a cluster is not just deploying a Kubernetes CR. It's also going to be you first set up your cluster, and then you set up maybe a dashboard with it, you set up some alerts along with it, you set up CDC, you set up users, and all of that. So typically, we realize that most of our database operations are kind of multi-step processes in a way, like deployment operations. So we have used Temporal, which is a workflow orchestration engine, to build a control plane, which kind of models this. So what we essentially have is, you have a control plane where a team who wants to sort of provision a cluster just gives you some specification, and you submit those jobs, and those jobs essentially go in and they work with all of the dependencies we need. So that might be, TiDB operator to just deploy the cluster. It might be cloud APIs, maybe to, set up some DNS, load balancer and stuff. You might actually interact with the Kubernetes API server to create additional components which sort of go with it and so on. And the control plane is like the interface we expose to platform teams, and we take care of all of this complexity ourselves. So what this control plane provides us is basically features like concurrency control, safety checks, and so on. So if I'm in the middle of a major upgrade, I don't want someone else to go and try to scale up the cluster at that point. So the control plane sort of ensures that if you have multiple operations on a cluster, it's kind of sequenced. You also have different safety checks, like if I'm trying to scale up the cluster, do I really have the capacity to scale up the cluster at this point? So it lets us put in all these kind of safety mechanisms and reuse them wherever needed. And this is something which we have invested in over the last year to basically sort of start managing our deployments. Now, we still kind of consider ourselves fairly early in our adoption of TiDB. We have a long way to go, essentially. So even though we have 300 clusters, we're still sort of learning how to do things better. And I'm going to walk you through a couple of examples of operational workflows, which we are building right now on top of like what TiDB offers to meet our deployment requirements. So the first thing is auto-scaling. So like I said, we use the self-managed Kubernetes deployment, which means that we don't get like auto-scaling out of the box like TiDB Cloud. So in our earlier approach, like I mentioned, we picked our most critical workload and then did the migration. So what that means is what was very important for us was to make sure that there's no downtime and stuff. So we did not optimize on cost in our first iteration. So what that means is even though we know our load is spiky and there's going to be ups and downs, we still make sure that we figure out the peak load and we always over provision so that we are well within the peak load limit. And this was fine for our initial approach, right? Like, I mean, you're just trying to get your functionality working, and that approach worked fine. But right now what we are working on is sort of like adapting to the load, and this is something the control plane has been sort of like working on building. So we sort of have like a periodic check in the background. It keeps track of various metrics. So for example, the CPU utilization, the average CPU utilization of the whole cluster in terms of TiDB, TiKV, and it takes like corrective action as needed. Now, there are like a lot of factors which comes in. Like for example, if it is TiKV, you obviously need to be more like conservative. Like, it's going to take a lot of time to rebalance. So make sure you start your operations like way ahead of when you really need it. If it's TiDB, you can probably do it like, as and when needed. So, and there might be some clusters which are like more important than others. So you need to be like more careful with them. So we made sure that our control plane is aware of all of these signals, and it takes all of that information in and sort of decides what to do. And auto-scaling is also going to be the first step in our kind of like goal of making a lot of stuff in like in our deployment setup to be auto-remediated. What I mean is, I think someone else also talked about it earlier, but we don't want an on-call engineer to be alerted for every single thing which goes wrong with TiDB. So we want our system to be sort of self-healing and try to like sort of fix itself. So this is like one of the first steps in that direction. Another thing which we have been working on recently is a major version upgrade through a blue-green deployment. So in TiDB, I mean, of course, like all updates are rolling upgrades, and you can, of course, like upgrade. But one thing which did not work out for us was that major version upgrades don't have guarantees of rollback. And being able to roll back any operation we do is something critical for us at Databricks. So we don't, we don't do operations where we cannot essentially like roll back safely. So for that, we have sort of built a kind of blue-green deployment kind of setup, which I think we work with PingCap to sort of design it also. So essentially, it's like you have a cluster and you want to upgrade it to the next major version, but you don't want to directly do it. So what you do is you use the control plane to spin up a new cluster, and it orchestrates things like creating it, restoring a snapshot of the blue cluster to sort of bring it up, then sets up TiCDC change feeds between the two clusters to catch up the the green cluster with the blue cluster. So essentially, you end up with a system where like now both of the clusters are having the same data and everything. Then you take the risky operation, which is a major version upgrade in this case, and you do it on the green cluster. All your clients are still kind of connecting to your blue cluster, so it's totally fine. If something goes wrong, you can always fix it, roll back and stuff. But once you're confident that the change is fine and everything is stabilized, then you sort of switch over. That is, you make your clients connect to the green cluster, like we do it on an automatic way, of course. So, so that clients are not even aware that this whole thing has happened, and their workloads just continue uninterrupted. This is also something which we feel will be helpful for us to move our workloads between like different Kubernetes clusters and so on. Like when you're dealing with multi-cloud, multi-regional deployments, this is something which comes up often. So these are the kind of things which we have been building with TiDB so far. So talking about the current state, I think I already talked about the current state, which is 300 plus clusters in 2 regions. And our current focus is on sort of having a mature control plane that is giving a way for us to be able to manage all of this with very less overhead. And of course, we are like focusing on things like auto-scaling, auto-remediation, and blue-green upgrades. These are the things which we are building right now, and we are hoping like this will get our infrastructure stable. but are looking ahead into our plans, let's say like a year or two down the line, we expect this footprint to sort of expand to like 1,000 plus clusters as we onboard more of our tenants to TiDB. And of course, like we are going to expand to GCP also. And specifically about the features which we are excited about building on TiDB. The first one is multi-tenancy. So until now, like I mentioned, we have been following a single tenant kind of model, which means that each team kind of has their own TiDB cluster and everything, which is why the number of clusters is also huge. But we understand that, that's not a scalable solution. Like we cannot just keep creating one TiDB cluster for each MySQL instance. So our current approach of single tenant migration has been limited to the most critical workloads, only the high throughput systems and so on. So once we are done with that critical mass, for the rest of the smaller workloads, we want to explore like multi-tenancy options provided by TiDB to have all of them on a single like shared cluster. So that's something which we are planning to invest in the next year or so. We also want to set up geo-replication. So right now we have set up like a zonal level of fault tolerance and stuff. We want to expand that to be like regional. So again, like TiCDC and some of the features here will help us out in that also. And our focus is also going to be on cost efficiency. Like I said, until now we have always been trying to like sort of get things working. So we are also planning to get into a mode of more cost efficient systems. And like that's kind of like a plan for TiDB at Databricks. And we've had a good experience like collaborating with PinkApp so far. In fact, for a lot of features like blue-green upgrades, multi-tenancy, and so on, we have actually collaborated like very closely with them, like sharing designs and so on. So it's been a great experience so far, and happy to see so many people interested in this as well. Thank you.